Good morning, good afternoon, good evening. Welcome to the online presentation of the MPAI Call for Technologies Pursuing Goals in Metaverse. This is the general project. Inside, we have a sub-project that is called Autonomous User Architecture, which is the first step in this larger project. So what are the considerations that have convinced that this project makes sense and is needed? A metaverse can hold different societies. I mean, you can think of an infinite variety of societies, but you have basic elements. Humans, I mean, not the actual humans, but they are digital representatives, and non-humans, like non-performing characters, which exist today. They are not particularly smart. And what we see is that there is not a lot of autonomous agents around yet, but there will be interesting opportunities if we can make agents that are affordable in terms of unitary cost and operation cost, reconfigurable and extensible. Reconfigure means that they can swap updated modules, and extensible. We can add or we can replace competence based on the context. We are well aware that autonomous agents are a complex system, and they need a variety of technology in order to perform their duty. And from our experience, standard can facilitate integration of the independently developed technology into autonomous agents that are effective and cohesive. We are talking about the standards, and MPAI is a standards organization. As you see here, is an international, non-affiliated, and not-profit standards organization. It develops AI-based data coding standards, and it does that within a clear intellectual property rights licensing framework. I'm not going to develop these notions here, particularly the last, but everything can be found on the website where you have the call for technologies. How do we develop standards? It's good to know because so we can map what we are doing today into our process. We have an idea. We collect interest. We develop use cases that fall in that idea. We develop functional requirements for the solution, for the standard. And when this is done, we develop what is called a commercial requirement, but actually it is a framework license. We then call for technology, which is exactly what we are doing right now. So this is where we are today in this process. We have more, because once we have responses from the call, we can develop the standard. When the standard is, we believe, is ready, we make a publication calling for community comments, and after that, we publish the technical specification followed by the reference software conformance testing and performance assessment. This is our process. As you see, is well structured, and we rigorously follow this process. So MPAI was established about 5 years ago, but we have not been idle. We have now 15 standards that are published. Actually, more versions of the same standards have been already published. What we see marked in red are the standards that we believe have an impact on what we are doing, what we intend to do with this process. The first is the AI framework. The second is context-based audio enhancement. The third is human and machine communication. The fourth is the MPAI metaverse model. The fifth is multimodal conversation. The sixth is object and scene description, and the seventh is portable avatar format. So all these standards are, we believe, highly relevant to what we intended to do here. But this relevance is not conceptual, but can rely on the output, which is the data types and other elements that I'm going to describe in a second. Because there are two foundational standards for which I wanted to spend a few words. The first is the AI framework, and the other is the MPAI metaverse model. What is the AI framework? It's a standard. It specifies the architecture, the interfaces, the protocols, and the API of the AI framework. And the AI framework is an environment where we can integrate AI modules with known interfaces, but unknown internals, into modular AI workflows executed in the standard AI framework. Why do we intend to make reference to this standard? It's because an autonomous agent, I mean, it can be considered as a monolithic thing, but this is not the MPAI approach. Whenever possible, we try to identify subsystems for which we specify the interfaces and the operation, but not the internal. So that's why we call this subsystem black boxes. Have known interfaces, and these black boxes can utilize different technologies from different fields. Our goal is to develop, to promote the development of an industry of autonomous agents in virtual spaces. So this is a graphical representation of the thing. You see that we have modules here, the combination of the module, the integration of the modules it gives an AI workflow. This is operated and it uses the API controllers, the controller API, and below we have other APIs for communication, global storage, access, and security. We have a large number of assets that we have developed in these 5 years. We have probably 100 AI modules that have already been specified, and probably 200 data types, which is what AI modules exchange, and you will hear this word quite a few times today. So the MPAI metaverse model technology specifies an environment where processes perform actions on processes and things called items, or request other processes to perform actions on their behalf. In this case, it's called process action. So this is the key elements of the MPAI metaverse model. And based on this, we have developed this very sophisticated specification. It is important to say that a type of process is a user. A user is not the user as a physical thing, but it is the process representing the human in the metaverse. Then we can also have autonomous users. They are still, the users are still responsible for autonomous users, but these users are autonomous in the sense they can operate with high degree of autonomy. So here we have an example of what we mean by an MPAI metaverse. So we see that we have a human. A human is using a device to control his user. The device can also have app. The device can capture a physical object and can make it an item in the metaverse. Important, a user can be rendered as a persona. Persona is a rendering of the user. It is not necessarily the rendering of the human. Uh, then we have service, and I mean, let's say that this is an element of the one of metaverse. Then we have another another metaverse, and we have this service called resolution service through which a metaverse can talk to another. I mean, well, all this is specified in MPAI Metaverse Modern Technology versions 2.1. So, a few more about processes. Um, Processes can be characterized as services, devices, and apps. They are all processes, but you know it's useful to consider them in this way. In particular, the user, as I have already explained, a human control a user directly, and in that case it is an H user, or indirectly, and in that case it is an A user. And here we have the things, the actions that a process can perform. So, for instance, an action is I want to discover items that are similar to this one. How can I do it? Well, I can contact a service that knows how to do that. I wanted to place my avatar somewhere, and then I wanted to animate it, or I wanted to move a chair. I mean, all these are things that that are specific processes that can be implemented directly by the user, H user or A user, or indirectly via a process. Okay, 2 words about this standard project, 2 words about some use cases, the functional requirement that we have derived from the use cases, and what the call is about, how the responses will be reviewed, and how the standard will be developed. First, what is the goal of pursuing goals in metaverse autonomous user architecture? It is to specify the architecture of an A user in the form of an AI workflow, and the components of the A user, which we assume are AI module, in terms of what the AI modules do, the functions, and the data types that are exchanged by the AIMs. If we do that, we can make a significant step beyond what we have achieved in the MPAI Metaverse model. We have given the ability to processes to perform actions or process actions. Now we want to give them the means for an A user to decide what to do in the metaverse, because that is the scope of the standard. So here we have a use case, which is buying eyewear in a metaverse. So imagine that this lady, Kate, wants to buy an eyewear in the metaverse, in a virtual shop there. A limb is a user acting as a sales agent. The A says that it is an autonomous user, and Mary is a human that may take over the customer interaction in case the autonomous user is unable to perform its duty. We have the goals, what Kate needs to do, Limbs must do, and Mary as well. And the workflow is that, okay, we have Kate explain her needs, Limbs places samples on the counter, Kate tries various samples in different lights and observes the effect. Limbs assesses and comments on Kate's appearance. Kate negotiates the cost of selected eyewear, and here where the problem is, because A-Lim applies negotiation, what is learned during its training, but phase, and therefore it calls Mary, and Mary closes the sale with Kate. So we have two more, but there are many more in the document. So here we have an avatar which is representing, is rendering an autonomous user. This avatar wants to follow another avatar, which is the representation of another user. It can be an H user, it can be an A user. That is not really relevant. And so here you have the conditions for the goal and the constraints for doing that. Marketing in the metaverse is much more sophisticated use case, because essentially you have 5 users. 3 are human and 2 are autonomous. Fiona is walking in the metaverse. Gary, the autonomous user, has been deployed to promote the products in the metaverse. Henry walks in the metaverse to meet friends, and Ian is, is the police in the metaverse, ensuring that people are not disturbed by impertinent users. And John takes over Ian's role in difficult situation. And here you have a list of goals that Gary, the autonomous user, has, and Ian, the cop, what goals it has. I will not go more in depth on this, and instead I will summarize the functional requirement. Of course, we can go in much more details with that, but let me stop at this level. The first thing that we say is that it should be implementable, the user should be implemented with limited computing resources. What is limited? Well, of course, this is not simple, but what we say is that, say, a 100 terabyte teraparameters LLM would not qualify as a limited computing resource solution. The user shall be able to understand its surrounding, including audio, visual, and text, converse with one user at a time in the metaverse, move in space in a human fashion, and understanding the constraint of the space and the fact that it should appear as a human, assume personalities, ethics, communication style, appearance, personal status. Personal status is what emotion you are expressing. It's more complicated than that, but that is an example. It should be implementable, shall be implementable for operation in the MPAI metaverse, but you know, it would not be so difficult to implement it in a different metaverse with language models that are relatively small. That is the goal. We wanted to balance the processing performed by the language model with the other more context-dependent processing that complements the lack of information from the language model. We assume access to the features available in the MPAI standard. Like I said, there are services in the metaverse that can be called. That is very useful to simplify the problem. Assuming access to domain knowledge. Again, because in the metaverse we can have a plurality of services. A user can access these services to face different situations. The user should, so before 1, 2, and 3 is a shall, number 4 is should, rely on existing standard or extension thereof. What we mean? We are very confident that our standards are good, but if there is a response that offers maybe the same solution, but with a different performance, we will gladly consider that proposal. it would be interesting to deal with more than one user at a time, and to be able to handle haptic information, because at the moment in the MPAI we don't have any technology for haptic. So then the summary. What is the main user scenario? We have a virtual space, a metaverse instance, with the audiovisual properties. This space includes at least one A user and one user. The second one can be an A user or can also be an H user. But the standard should not be dependent on the nature of the user. The autonomous user deals with one user at a time, but may switch to another user when it interacts in the metaverse. And the two users are engaged in conversation. For instance, they want to solve a problem. And so we have the user maybe asking questions, the user assisting, but in order to assist the user, of course, must understand what the user is doing, how it is reacting. I mean, there's a lot of things, and some of these you will see in a minute. Then both users can perform actions or process actions, but you know, in the MPAI metaverse, you cannot do everything you want, because you are given certain rights, but you may not have other rights. You may acquire them, but not necessarily. And then, and this is very fundamental, can access services in the metaverse based on their rights. For instance, the example that I was making, I want to discover a process, or I want to discover which objects are similar to this one. This is a service that the metaverse provides. So the conclusion is that the call for technologies was issued on the 29th of October. By the 29th of December, the Secretariat should receive a response from those who intended to make a submission. This is not mandatory, but is most welcome if this is done. And then we have an imperative deadline for submission of responses, which is the 19th of January 2026. And two days later, we will have a General Assembly, and the evaluation response will start at that time. The process will be that we have different working groups examine the different components of the responses, and we will retain those responses that are appropriate for the standard that we intended to develop. Of course, this will not be MPAI deciding. I mean, all these meetings will be conducted with the participation of respondents. Then MPAI will select suitable technologies from those submitted, but we are not obligated to select a particular proposal or any proposal if none satisfies the requirement. And then, this is most important, respondents will be encouraged to join MPAI, and those who have responses accepted shall join MPAI, and if they don't, their proposal will not be considered anymore. So this is the summary. But then, if you intended to respond, you should really look at what we have published on the website. So there's an important point that I must make. Actually, most of what I'm going to say next will be based on what is here, which is called tentative technical specification. What is this tentative technical specification? Is a document on the web that is part of the package of the documents in the call for technologies. This tentative technical specification is drafted using the style of an MPAI technical specification, but it is not an MPAI technical specification. It is simply an example of what MPAI is seeking to develop with this call for technologies. But it has no formal status. Respondents are free to comment on, change, extend the tentative technical specification if they want, but they can very well make proposals unrelated to the tentative technical specification, of course, in the framework of the call for technologies. Okay, so here I am deep in the tentative technical specification, and this is the reference model. As not unexpectedly, you will see that we are considering the AI framework. You will see here a big AI workflow, which includes some 10 AI modules. Let's analyze them one by one. The first is the autonomous user control, which does what the word says. It controls the AIMs, the AI modules in this workflow, which is good enough, but what does control mean? It depends. It depends on the implementation, or it depends on the actual use. In some cases, the A user just oversees what the other modules do. In other cases, kind of micromanages what these AI modules do. And the specification, the standard, should support both configurations. Let me start then to the analysis of the other, of the controlled AI modules. The first one is the capture of context. What is the context? Well, is the environment where the user resides. And a result of this capture, it can get text, I mean characters, it can be audio, in the sense that it can be speech or another audio, and then the speech is recognized and the text is obtained. Then we have the other data types like a 3D model, when you have the actual access to, say, the 3D message. And then we have visual, if we are capturing with a virtual camera, this will be visual. What is the result of the capture? It's something that is called context. We are going to see what context is, but here let me say that it is a description of the spatial environment and a description of the user state. The user state means that the user can be excited, the user can be doubtful, the user does not know where to move, or any other configuration. So we want to capture the state of the user with this data type, which of course will be a rather complex data type. Context is then processed by spatial reasoning. Spatial reasoning is actually two AI modules. One examines the visual part of the context of the scene, and the other examines the audio part of the scene. As a result of this reasoning, the scene descriptors that were received from context are enhanced by additional information, and is passed to two AI modules. One is the domain access, we'll examine later, and then we have the prompt creation. Prompt creation is an AI module that takes the text that may have been input via a keyboard or obtained by recognizing speech, and augments this text with the result of all the other information, the processing of the spatial information or the user state, to produce a prompt that is passed to the basic knowledge, which is a large language model, but not too large. As a result, the LLM produces a first response that we call initial response. It's passed to the domain access. What's the function of the domain? It's to give access to domain-specific information. By using that, the initial response can be augmented with another in the next prompt that will be passed to the basic knowledge. But then we have another function, because as a result of spatial reasoning, we have this augmented scene description, audio and visual, which is passed to domain access. And again, this gives additional information that is domain specific and is returned in the form of spatial directive. Let's continue with the flow of the prompt. Here we have a new prompt. The result is an enhanced response. Enhanced, why? Because now we have domain information, domain knowledge that has been added to the text. So the result is that we have the enhanced response is aware of domain knowledge. This is passed to the user state refinement, which, by the way, is already receiving the refined context guide from the domain access. And all this information is used to have a better understanding of the user state of mind, emotion, call it the way you want. So with this refined understanding of the user state, a new prompt is formulated that is processed by the basic knowledge, which responds with another refined response. But the user state refinement produces also this expressive state guide that is about saying, now I understand better what the user state is, so that personality alignment is in a position to make the right choice of which personality the A user should adopt in order to deal with the specific user state. So this is something that we have done in our standards, where we always said, okay, now I understand what the user outside says and how it feels about all, and then let's give a response that has a given personality, a given personal status, like we call it in MPAI. Now we try to provide a solution to the fact that we have a given user state, and we want to know how we can generate this user personal status. It's no longer in the scope, limited scope of our previous standards. So the result of all this is that we have a new, and it is the fourth, but it is the last prompt from personality alignment, that now this prompt has been enhanced by the information about the autonomous user's personality. So as a result, we have a final response And here we are entering a space that we have been dealing with um, for several years, which is how do we render an avatar that is saying something, this final response, with a particular personal status. So this is a problem that we have solved. Here we have an additional case that the user control may say, you may want to say these things while you are happy, but you are better to mitigate your happiness. I mean, the user control may exercise this level of control. Now that the user, the avatar, has been created, now the avatar must be rendered. And here is where being in the MPAI metaverse model is useful, because we can apply a process action request to a service to render this user. And of course, this will be just the response that is given to this request. So this has been a long story, but I think it was important to give the essence of the approach that we intended to follow. Of course, if people have different ideas, they want to modify what we have proposed, or they want to provide a new approach. We will be very happy to consider that, because we want to develop the best standard, not our standard. I mean, the result is that it will be ours, but we want to be our standard and a performing one. So let me see now an in-depth analysis of what the context capture is. So we call it, again, this is an example. It's not a specification. It's an example. But you know, if this is accepted, this will become the basis for the AIM specification of context capture. So here we have what it says. It receives this we have said. We have said that it extracts, refines, interprets multimodal signal, and the goal is to construct context, which includes the space information, where is the user, and then semantic tagging, framing of cognitive, emotion, attentional, and temporal state of the user. Then the context is sent, like we said, to three directions. The prompt creation, which will interrogate the LLM, the domain access, and a user control. And will enable domain access and prompt creation to operate with full awareness of the environment, and the user control, because this is the response to any directive that was given by the user control. So this is the specification of the input data. So all these data are already existing. Well, not all, but most are existing in our repertoire of standards. And and this is how we think context capture can be articulated. So we have the audio and the visual description. They are in charge of creating, of describing the audio scene and the visual scene. The audio scene and the visual scene is composed of objects, and then with this, we wanted to identify what is the nature of this object. That's why we have an AIM, it's already existing, that is called audio object identification, that will tell me this audio, say, is a siren, or this audio is an angry speech, and same for the visual. Then we have the need to align the audio object with the visual object, and this is the target of the audio-visual alignment AIMs. Then, when we have the audio scene descriptors and the visual scene descriptors, I will say in a minute about this too, we are in a position to extract the user state. This audio, of course, includes speech, everything, and so on. The result is the user state, and the output is the integration of context and context capture state. What is context capture state? Is the response to the context capture directive that the user control may have given to this AI module. So with that, here we have a long description of how the AIM specification could look like, AIM by AIM. And with that, I have concluded the first example, and now I go to the second example, which is about spatial reasoning. So here we have, again, we receive context, visual spatial directive, and visual action directives. We extract, refine, interpret, and sense the visual scene descriptors, and enables the AIM to operate with all the information concerning the visual environment. Here we have the input and output data. Again, context. I mean, we have an initial specification of context, again, subject to much refinement that I'm sure will happen in the future, or no refinement at all if we decide to take another approach proposed by a response. The visual spatial directive comes from the user control, and then we have the visual scene description and the visual action state, which is the response. Here is the architecture of the visual spatial reasoning. So here it is different because we already receive the visual scene descriptors. So we know the objects and their positions, but we needed to do more than that. So here, for instance, we want to estimate the depth, the distance from the user, and the occlusion of any occlusion that may happen. This is an assessment of the affordance. How can I reach this object, or maybe I'm unable to reach that object. And finally, we have the salience mapping, which is about creating, say, which are the salient visual objects, how well can I interact with a particular object, the depth from the user. I mean, we have a lot of this data that are integrated in this visual output construction, which contains a visual scene description. That's what I have said before. We receive a visual scene descriptor and we produce as output another visual scene descriptor that is just the extension, the enhancement, the augmentation of the input visual scene description. And the visual spatial state is, as usual, the response of this AIM to this visual spatial directive generated by the user control. So we have much more information that is given here. You will understand the level of complexity that is behind all this. Don't expect this to be a walk in the park. But let me go now to the third case, which is interesting because here we are seeing how we are interfacing the physical world and the physical world here is captured by context, integrated by spatial reasoning and the understanding of the user state, with the large language model, the basic knowledge. So the function of this is to receive text and audio and visual, and also visual syntax created from visual spatial reasoning and domain access. Synthesizes multimodal and contextual signals into natural language prompt and providing the prompt to the basic knowledge AIM, and the result will be used in the further steps in the AI workflow. So here we have the list of the input and output document, output data types. So you see we have the context, of course. We have the audio syntax creators enhanced by the visual reasoning, visual spatial reasoning. Here we have the visual syntax descriptors, the prompt creation directive. So let me just explain. Here we are in the in the prompt creation. Therefore, we have the visual syntax creator, but we also have the audio syntax creator, even though I did not introduce them to you. The output is a prompt, and then we have as output also the response to the user control in case it has decided to intervene in the creation of the prompt. So here we have another list of elements that process the data. I'm not going to spend the time on it. Just a little remark concerning this prompt planner. So here we are dealing with a lot of sophisticated technologies that provide different types of data. All these data are integrated in a JSON schema that aggregates all semantic inputs into something that we call the prompt plan, which is not the plan, not the prompt. It's just a plan because it is a JSON schema, and this prompt formatter converts the JSON schema into natural language that is actually provided to the LLM. And here we have the user report to the a user control. Now we are coming to a close. We are well equipped to handle this standard project. We have AI framework group, a context-based audio enhancement group, a multimodal conversation group, object and syntax creation, portable avatar form, all these groups we have, but we are keen to receive your proposal in the different technology areas required by this new project. For your information, the yearly membership fees for MPAI are 2,400 euros if you are principal member, and 480 euros if you are an associate. But remember that from the viewpoint of participation in the standard development, the rights of this user are absolutely the same. Principal have a say in the evolution of MPAI, but not in the development of standard. If you join now, your membership will be until the 31st of December 2026. With that, I really look forward to welcoming you in this exciting MPAI project. This is the link that I recommend you to follow to see the call for technologies and this tentative technical specification. With that, join MPAI, share the fun, and build the future.